In this video, I'll teach you how to become an Azure AI Search Pro. You'll learn everything, from setup to simple search, from vectors to hybrid search, from RAG for AI agents, and so much more. I'm a Microsoft Azure MVP, here to guide you on your journey. Now, if you're ready to become an expert in Azure AI Search, let's jump into our first session on the basics of Azure AI Search. Azure AI Search is a cloud service that transforms your data into intelligent, AI-powered searchable insights. Azure AI Search is made up of two primary components, its indexing engine and its query engine. You start by having content that is either structured or unstructured. This content is used to create a search index where data is mapped directly or transformed with AI based on your search requirements. Then you can search an index with different types of queries, from simple keyword lookups to complex AI-assisted queries. So why use Azure AI Search? You can search with any type of data, images, audio, or even multilingual text. You can get answers exactly how you need them, where AI can even enhance your search for better results. And supercharge your AI apps with RAG by giving your apps the knowledge they need to quickly respond to end-user queries. So when should you use Azure AI Search? You should use Azure AI Search anytime you want to quickly retrieve specific knowledge based on a large, complex data set. Now that we've gone over the basics, let's create our first Azure AI Search resource. So I'm in a new resource group, and I'll go to create my first resource within this resource group. I'll search AI Search. I'll find Azure AI Search, start creating now. Got your basic subscription, resource group, which I already have. I'll call this Search AIS, East US 2, Demo, AI Search. I'll make it East US. Now, when it comes to pricing tiers within Azure AI Search, I'll share a bit about this. There's a whole bunch of different SKUs you can look at. And the offerings, they go from small to high. To describe a little bit how these things work, indexes are the actual, it's the actual storage of where your data is actually living. So the way your index actually is going to hold all the data, it's within what's called the index. So like a database has a structured database with rows and columns, your index is in the search world. When it comes to search engines, it's the actual database that's holding all of the data so that it's easily and quickly accessible. An indexer is what's used so that you can actually create that index. So you'll ingest data and actually build an index using the indexer to be able to map data the proper way from your data source. Your vector quota is how much data you can store in terms of vectors. You might also hear the term embedding, which is referred to as a vector in the AI world, but an embedding is it's another way of saying vector with a slightly different concept. So an embedding or vector quota is per partition what's listed here. This total storage is everything that you can have for that index. So this includes your vector quota. So if I were to choose standard, which is what I will choose here, I can have 35 gigabytes per partition or 160 gigabytes for total storage. So 35 gigabytes of that total storage can be vector quota. Doesn't have to be, but I can't have more than 35 gigabytes of vector storage within this unless I up my partitions. I'll move these a little bit so you can see there's search units. Search units is basically a form of measurement that Microsoft uses to be able to quote the usage of the Azure AI search resource. There's a lot of compute and infrastructure behind the scenes of what goes down to make this work. So a search unit is the maximum amount of this infrastructure and compute that they have put together that can be available depending on the tier you have. So for the free tier, your search unit is always a product of your replicas, your number of replicas, multiplied by your number of partitions. So if you were to have the maximum amount of search units you could have is 9 if you have 3 replicas, 3 partitions, 3 times 3 is 9. But just so you know, search units, you could have 36 in the standard, and while you could have 12 replicas, or you could have 12 partitions, you certainly can't have all 12 for replicas and all 12 partitions, because that's 144 search units, not 36. So you would need to play around with how much you have of each if you wanted to maximize your search units depending on your other tiers. Things to keep in mind. This also does get pretty expensive. So as you'll see when we select an option, that one search unit, this is the cost. So if you increase to multiple search units, you'll see the cost go up, and you'll see that in just a second. So I am going to choose the standard tier here, because I am going to get rid of this later. For the compute type, you do have the option of choosing confidential computing. For those of you who don't know what confidential computing is that in general, a lot of times data is encrypted at rest when it's sitting in a database. It's encrypted in transit when it's going over a network. But when it's executing compute or code, when it's processing is another term, it's technically being decrypted, read, processed, and then encrypted again when it's placed somewhere. If there are people or businesses in a regulatory position where you need to have very safe and secure processing requirements, meaning something that has logic executing on it and needs to also be encrypted, you might need confidential computing, but most people don't. So next we'll go to scale. So scaling, this section is all about how many replicas or partitions do you need. I would say generally you're always going to start with just one. Don't worry about having more replicas. And a replica is just a copy of your index. So if you have one index that can service a bunch of requests and responses, and you find that it starts to go slow in terms of its response time, you might need to up the replicas so that you have more concurrent request responses that you can make. So only need to increase your replicas once you have a large amount of requests. Now, if you are a big business or an enterprise, you might know that you need more replicas from the very beginning. But you first want to establish a baseline to know how many requests and response you might have with one replica when you're developing your solution, and then only add replicas as you need once you know your baseline, depending on your solution. There are some benefits to starting off in terms of SLAs with multiple replicas as well, which you can see here and here. Partitions is just an additional set of compute and also storage that you can add to your AI search resource, as this is helpful if you have a large index that will go over the storage for a single partition, where you'll need multiple partitions to cover that entire index. This also helps with some of the compute that can help increase the speed and efficiency of your indexing. So when documents are coming into your data source and they need to be indexed to add to your index from your indexer, having more partitions gives you more compute to make that process go faster as well. Networking, there's some basic networking you can have if you want this to be public or if you want to set up a private endpoint. Then there's tags, then you can review and create, which I will do. My resource is created, I'll go to it. And on this overview page, some things to point out is now this is where you'd start adding information if you wanted to create your first index. So I have the option to create an index manually in the Azure portal, where I could start adding fields and I can decide what their field attributes are. In a future video, I'll go over how these specific fields work. when it comes to querying. You can import data using two different types of import wizards right now. This is the old form of importing data, but there is a new form which is labeled new. You'll choose your data source, follow the wizard to create your index, indexer, maybe your skill set, that type of thing. Your Search Explorer takes you straight to where you can start querying on indexes that you have. And then you'll see some of the basic information. Down here, you'll get a little bit of this, the basic steps to this import is just taking you the first import data. If you want to view some of the data that you already have, some metrics, you can check out some properties that you have once you have indexes in here to see what is available to you. What is your quota? How much of your vector quota have you used? How much of your total quota for the partitions and total resources that are available? You want to jump to your API keys, see your connectivity, all that stuff. The usage, you can also see with these charts, make it easier if you're a visual learner. Monitoring to see how well your AI search is being used, how fast it is, how many queries per second. This is helpful to help you determine, one, the performance, two, do you need to add replicas or partitions, things like that. You'll be living in the search management section quite a bit using Azure AI Search. The indexes are where you'll actually have and find your indexes that are available in this AI search resource. The indexers are the tools that map your indexes from data sources and skill sets to create that index. Your data sources are where the original data is stored that's being indexed into your index. An alias is a way so that you can map to an index without having to change underlying code. So if you're using a software development kit, an SDK to make calls to your AI search resource, you might have an alias that maps to a index, but could also then change the underlying index so that if you map to an alias, you can switch the index that alias is mapping to so that it's easy to make changes from one index to another and without any underlying code needing to change. So that way you don't need to hard code a specific index. Even with environment variables, you can just map to an alias, and then in your AI search resource, you can change the index that an alias is mapped to without affecting an application that's using that alias. Skill sets are what are necessary to help enrich or add enhancements to the mapping of data from a data source to your index. It's also what's used to create the embeddings for vectors in your index. Debug sessions are what you'll use if you're trying to figure out why an indexer is not working. Things are breaking in the way that the mapping is working, in the way that the indexing is happening. You can use debug sessions as a form of trying to understand what's wrong and trying to fix what's going on. The last couple sections that you'll probably use quite a bit are the keys section and also the scaling section. If you want to scale or take a look at your keys for using your Azure AI Search. Everything else is pretty self-explanatory, but that is Azure AI Search in a nutshell.
We've learned how to create our Azure AI Search resource. Now let's actually use it by importing data for a traditional keyword search scenario.
Now to be clear, full text search is more of traditional search where you search based on keyword. There might be some fuzzy matching, some relevance involved, but there's no vectors, and it's not ideal for AI agent solutions. But this is great for if you're searching a product catalog or if you're on some sort of search engine and you need to search based on keyword, or for your application that needs to search by keyword for a specific product or some sort of category, things like that. So I'm in my Azure AI Search resource. Let's start by going to import data, where we can see we need to import from a data source. This is going to be the wizard we use when we are setting up our index, our indexer, which will do mapping from our data source to our index. So now we need a data source. we need a blob storage account, or we could use something else, but we'll use blob storage account in this example. Right now, since we don't have a blob storage account, let's create that. So in our resource group, we don't have a storage account. Let's create one. We'll go to create within the resource group. We'll type in storage account. Create a storage account. We're going to put in some basic info here. SA, AIS, East US 2, because that is the actual region it will be in. Sticking with my naming standard here. So we have basic blob storage. We're using this for AI ultimately. Standard performance. We'll make this locally redundant because it's cheaper. And then we will review and create. No need to get into the weeds on the storage account. There's a lot you can do, but I'm okay with the defaults for what we're doing here. For reference, while this is being created, what we're going to be uploading to our storage account is this list of JSON files, which is each one of these JSON files is a product in the fictional Frankie's Bakery that I have, where we sell cookies and brownies and breads and all kinds of goodies. Each one of these JSON files is a product. It looks like this. Here's an example with just a description, some categories, product ID, ingredients, price, things that we can easily map and understand for the way we can search for things in Azure AI Search. So it's just a list of these. That's what we're going to be uploading, all 20 of those. Our deployment is complete. Let's go to our resource. We'll create a new container, blob containers, add container. Let's call it Frankie's Bakery product catalog. We'll create it. We'll go into this, select upload. Oh, looks like it needs to load again. Let's give that another try. Might be going too fast. Go to there, go to upload. There we go. We'll bring in all those JSON files, upload them. Now we have all of our JSON files with each of those different products within our Frankie's Bakery product catalog. Now let's head back to our AI Search resource where we'll start filling out this wizard. I'll choose Azure Blob Storage. At this point, you choose the scenario that you're targeting, which will determine the type of wizard that you continue going through. If I was going to set up a new AI search with an indexer, an index, a skill set, I wanted to use vectors and embeddings for an AI agent, I might choose RAG, multimodal RAG. If you have images that you also need to understand with an AI model that can understand images, you might choose multimodal RAG. We are only using full text search, which is keyword search. This is not going to involve adding another AI model that is going to create vectors. It's simply going to map from the data source to the index, and so there's not any type of AI enrichment, any type of special skills that are necessary, so we won't have a skill set. We're just doing something more basic in this one. I'll choose my storage account, choose my blob storage container, and if you wanted to get more granular with the folder, you could do that here. We're just going to use everything within the container, so I won't specify another subfolder. When it comes to parsing, this is going to be important depending on the type of files that you have in that container. By default, it's just going to bring everything in. It's going to try to figure out best it can what to use. We want it to be really specific, so the files we have are not just generic PDFs or anything like that. We have specific JSON files, so we want the indexer to be able to parse these files are JSON, so that's what we'll choose, the parsing mode. Enable deletion tracking. This is for if you want to update your index if you remove items from your Azure Blob Storage container. For example, if I have the list of 20 products and I'm searching through products on my application, but now I want to remove a product from my product catalog, I might delete it from my Blob Storage container, which will be deleted using the soft delete feature that is enabled in the Blob Storage account. And then my index will get updated to remove that product if I enable deletion tracking, because the indexer will then understand, hey, that item has been soft deleted in Blob Storage. Let's update our index to not include that item that has been removed. I won't select that now. Authenticate using managed identity. If you don't want to use API keys for your AI search resource to interact with your storage account, you can use managed identity. This is recommended for production. I won't click it now because I just want to keep things more simple. If you want to enrich your data, you could use AI models that will add additional features to enrich the data. If you want to extract certain entities, locations, people, phrases, change the way things are formatted with the text, you have that option. Again, keeping things simple, we won't do that. You can see the way your fields are going to be mapped from your data source, both the actual content itself and also the metadata into your index field. So this is what your index is going to look like. These are the index field types. And if you want to change the way you can query that data, the fields that are available, there's things to make them more searchable. These three dots here. We click configure if you want to make them filterable, sortable, faceable. If you are trying to get a list of the products and quantities for some sort of sorting page on your application, you can change these here. Keep in mind when you add these, it makes your index bigger, sometimes a little slower. So by default, most of them are not enabled. In this wizard, you might not enable them unless you really need them. If you want more of those, maybe you'll set up your index in a more of an SDK environment or using a REST API. Since that's looking good, we'll move on to the indexing schedule. So right now this is set to run on its own one time. You could set this up to run periodically. Remember, when it comes to the cost of your AI search resource, you pay for your partitions and your replicas, and you'll only pay any additional cost if there are AI enrichments or enhancements using AI models where you need to pay for the input and output tokens. So it doesn't cost you anything extra to have your AI search resource index on a regular basis. And keep in mind too, by default, your indexer will only actually index items that are new. So if you have it run periodically and you don't add anything new to your blob storage, it just runs very quickly because it doesn't find any new documents. But it'll only pick up the new documents if you add them. I'll disable semantic ranker, but just so you're aware of what it is, semantic ranker is a form of search that allows your text or data to be searchable based on the semantics of the words themselves, not just the keywords alone. So there is additional complexity that gets added there, but it also helps your AI search solution better rank the types of results coming back based on the semantics and the meaning and intent of a query, and not only just the keyword. All right, now let's create a name. Full text, we'll call it full text search. This is the name of our index. And we'll create it. This start searching will take us to our search explorer, where I can hit search and see all of my items coming back. So I had 20 items that I uploaded. I can see there's 20. Only some fields are coming back, but if I go to fields, I can see the different types of things available. You can see the filterable, sortable, all the way to searchable are more grayed out. These are immutable and you can't change them after your index is created. If you did want to change them, you'd want to take a look at this JSON file for your index. You could take this, copy it, you could use it in an SDK, and you could create a new index where the items that you need to be true are true. The retrievable is always available to change because this just decides what comes back within your actual queries. So if I check all those and I save, I can see now in my Search Explorer that more data comes back. If I didn't want a lot of these, I could remove all of these and just have something like the title and description come back. Save this, Search Explorer, search and see just the title, ID, and subscription that are returned. When you're ready to get started using your AI search solution, you'll need your URL to access your AI search resource. You'll probably need your keys, or if you're using managed identity, you'll need to switch on managed identity here. Those are the two ways you can access your AI search resource, is by either using the API keys or managed identity using it in an SDK. I can also see my indexes. I'll see my full text search index. I can go to my indexer and see my full text search indexer, and I can go to my data sources and see my full text search data source. And that's how you use full text search in Azure AI Search.
Keyword search is the most traditional form of search. But if we want to take it to the next level, where we search not just based on keyword, but also based on the semantic understanding of those words themselves, we need to add vector embeddings. When you add vector and keyword search together, you get hybrid search. Let's add that now.
Now, just before we dive in, let's go over a couple definitions. For example, what is a vector? A vector is just a list of numbers that represents something that computers can understand. So if we have a list of numbers in all these different matrices, we would call them a vector, and it's just got all these different points that might be different dimensions to represent something. If we put something on a plane, say it's two-dimensional, say it only has an X and a Y point in the dimensions, we could put it on here and have 4 data points on an X and Y axes. An embedding is just a special kind of vector. It's a vector that has some sort of meaning or features that are captured within the numbers to represent something. So we might have a multi-dimensional vector that has lots of different dimensions that represents, for example, a man, woman, queen, king. And in those dimensions is the meaning of how a man relates to a woman or a queen relates to a king. And all of those play a factor into how the vector is created. And then later, how the vectors relate to one another. So the distance between them in vector space is then what's used to create the determination by something like Azure AI Search as to how close they are in vector space to then rank them when it comes to search results that use vector queries, where vector queries are querying for embeddings. So in the AI world, you're going to hear vector embeddings or embedding vectors, and it's the same thing. When you hear a vector, though, or the term embedding, know that an embedding is just a special kind of vector. Now, that being said, let's add vectors to our AI search resource. Now, because we're doing this in the portal, the first thing we need to do is enable managed identity for our AI search resource. So we'll come down to identity under settings, and we'll turn on system assigned identity. Next, let's create an Azure AI Foundry instance. So we'll come to our resource group, create, we'll search AI Foundry, and we'll create a new Azure AI Foundry resource. This will create a new resource with one project underneath it. for Azure AI Foundry, AIS, east US to demo AI search. We'll make this first project called Proj AIS east US to demo AI search. Next, we'll leave all the networks open. We'll make sure to use system assigned identity. We'll leave the encryption, no tags, and we'll create this. Once this is done being created, we'll create a couple role assignments for our Azure AI Search managed identity so that it can have access to the AI Foundry resource and also the Azure Blob Storage resource. It's done being completed. Let's create those role assignments now. I'll go to Access Control. I can see in role assignments there's no role for my managed identity. Let's go to Add a new role assignment. The role assignment I'm going to add is the Cognitive Services OpenAI user role. This will let our managed identity access our embedding model. Find our search service, and we'll review and assign it. Next, let's make a role assignment for the Azure Blob Storage. Back to our resource group. Let's go to our storage account and make a role assignment in here. Go to Access Control, Role Assignments. We also see no managed identity role assignment. Add new role assignment. And for this one, it's going to be the Blob Data Contributor role. Review and assign, yes. Now the next thing we'll need to do is create an embedding model deployment that will actually vectorize the data both by our index and also when people make queries, and we need to vectorize those queries to then compare to our vectorized data so that then a query can do the cosine similarity and send back a response. Back in our resource group, let's go to our Azure AI Foundry resource, which will take us to Go Azure AI Foundry. You can also type in ai.azure.com. Now we're already within the project, and in this project, we'll go to Models and Deployment, Models and Endpoints. Then we'll deploy a model. And there's lots of models that are available to choose from. We're going to filter on the top here to filter for embeddings. Now these are all models that can now convert text into vector embeddings. These are our options. Text embedding, this is a balanced one that is, works well, decent price, decent quality and performance. These are the two newer versions that OpenAI has available. Large is more expensive but better performance. Small is cheaper but faster. We're going to use small for now. I'm less familiar with the Cohere models, but you could take a look at those if you'd like as well. And we'll call this Frankie's Bakery because that is the name of the fictional company that I have put together for demos where we sell cookies, bakeries, brownies, all kinds of things. Now this deployment is done. Keep this page up, this tab up, because we're going to need the endpoint, the model name, and the deployment, plus this key in just a moment. Now let's go back to our AI search resource, where we're actually going to add in our vector field. So we'll go to our index, full text search, go to fields, add a field. This field we'll call content vector. We'll change the type to be a collection of single, which is what will store all of our numeric vector. Now the dimensions of the vector is how much data can be stored for that vector, how many numbers, different dimensions, in order to make your vector store the meaning of words. The dimensions I'm going to use is based on this documentation that lists the supported dimensions for models. Since we're using the text embedding 3 small model, our maximum dimensions is 1536, which is what we're going to use for our dimensions. Now we need to choose a search profile, which will have an algorithm and a vectorizer in it. We'll create a new one since there isn't one that exists within this AI search resource. We'll call it my vector profile, and then we need to create a vectorizer and an algorithm. This algorithm will use the basic kind of HNSW, stands for hierarchical numeric search, something like that. It's the most standard newer version of a vector algorithm. There's also this KNN, which is another older version. It's not used quite as often. We'll call this my vector algo, and we'll leave these other defaults. So that's our algorithm. Now let's create our vectorizer. My vectorizer, this is where it's going to be important to connect to our embedding that we just created. The kind is not going to be OpenAI, it's going to be Azure AI Foundry. And we're going to keep our existing subscription, choose our project that we just created, our model deployment. In this part, usually I would assume that the system assigned managed identity would work, but this has been a little bit buggy and it's forced me to always choose the API key. So there might be something we're missing here. This might be a bug. I haven't dug into this enough, but we're just going to move forward and use the API key in that particular setting. We won't use a compression here. So now our index field that we're going to add for our vector is set. We'll save this. Now we see it here on the bottom. Now, because we added this and there's no skill set and the indexer hasn't run, this should break our index, meaning we won't be able to query now. If I go to Search Explorer and I try searching, we won't get back any content when before we would have. So because of this, we need to now update our indexer and create a skill set. So let's go back to our search resource. We'll go to skill sets. Let's add in a skill set. I have some existing code that I'll paste in here, which is the JSON for the skill set. You can get this info on the screen, or you can get the file in the Azure Innovation Station online community. There's a link to join, and it's free in the description. So in this skill set, we have the description, the name, and there's 2 types of skills. There's first this merge skill, which takes information from the description and the tags and adds them together to create a combined text field. This field is then what we're going to turn into a vector, so that when people are making vector queries, they're really going to be searching through text that is in this combined text field. That combined text field then will go into this second skill, which is the AI embedding skill. So this is where we need to put in some information in order to actually make this embedding work. So we'll go to our AI Foundry. Let's put in this resource, the endpoint, the deployment name, and the name of the model itself that we're using. Now what's happening with this embedding is that we're creating a vector embedding from the input of this combined text that was created from this merge text skill. And we're taking that combined text and we're creating an output of an embedding, which we're naming embedding, we're putting into a target field named embedding, which will map to our content vector field in the indexer. And then finally, we need to put in our key to make sure that we can use this Azure AI Foundry resource. So let's go to our key, copy that, and we'll paste this in here. Then we'll save our skill set. Now we'll go to our indexer, and let's update our indexer. We'll open up the JSON, and we just need to add an output mapping for our embedding skill to take the vector embedding from the embedding field and place it into the content vector. This is an output field because after the skill set runs, this is what needs to be outputted into the index. We'll save this, and we should be good to go. Now, if I reset my indexer, I can refresh and see that the reset worked. I can now run my indexer again. And see that my indexer has run. It's successful. All these documents have been succeeded. Now let's go to our index. We should be able to search again and get information back. We're not getting info. You know what? I realized I need to add our skill set to our indexer. Otherwise, our indexer has no idea what this skill set is. So let's copy this and go back to our indexer. Edit the JSON. And at the top, we see skill set null. Let's make sure that we add that in here. Now our indexer actually knows what skill set to use to create the embeddings, so this can work properly. Let's try this again. We'll reset this. Refresh. Run again. Refresh. Oh, we need to fix the embeddings. I think my pre-created code from the skill set had actually a different vector embedding number. It did. Let's make sure we update that. You're seeing the way people debug these AI solutions in the middle of this. Now we should be good. Let's run our indexer again. Now it succeeded. Now let's see if we can query our index. And see, now we see we get our content back along with our content vector, with all these numbers being the vector. If this is too much and you don't want to see all this, you can always turn off the content vector and save this. Now, if we wanted, we could search using vector queries, searching something like, cookie, ask for a few items back. And see some of our outputs where now the vector queries are working to add more semantic similarity, not just keyword search, to our AI search resource. We have a new index with a vector content field. We have a skill set that's added to create embeddings, and we have an updated indexer.
You know how to import simple data to create a search index, and how to add vectors on top of that index. But what if we wanted to start with vector search? Let's look at how we can import data to start with vector search the same way you would if you were setting up RAG for an Azure AI agent.
So right now, we'll start in this Azure resource group where we have an Azure AI Foundry resource, which has an Azure AI Foundry project, and also a storage account and a search resource. the first thing we'll do is upload some files to our storage account into a container that will be our data source. So I'll go into storage browser, blob containers, and I'll create a new container. I'm going to call it NASA ebook. The reason for this is because this is the data that we're using. So I'll show briefly this list of pages that we have. It's just a bunch of pages from a online book that NASA had with a bunch of information with images and data related to pictures. And here's a couple different pages where we're just looking at the text from these PDFs. We're not looking at anything related to the images, so the images aren't here. We're just pulling out the text from all these PDFs. So now in this NASA ebook, I'll go into the container. I'll upload these documents. Now that all the documents are uploaded, we'll go back to our resource group. So anytime you're setting up vector search, you need an AI model that can create a vector embedding by converting text into an embedding vector. So for this, we're going to go into Azure AI Foundry, where we're going to deploy an AI model that is specifically an embedding model, a model that creates the vector embeddings. We'll use this to create our vectors with our data, and also it'll be used to vectorize queries that are coming in as text to compare with the other vectors. So we'll go to Models and Endpoints within Azure AI Foundry. We see we already have one embedding model, but we're going to create a new embedding model for our specific use case. You can always search by the type of model name. I'm going to filter based on the inference task. We're using embeddings, so I'll filter based on that. I'll choose text embedding 3 small. It's cheaper and works well. And we'll call this NASA ebook. Will be our deployment name. Now back in our resource group, we'll go to our AI search resource. And now that our AI model for doing the embeddings is set up, and also our data is within our data source, which is in Azure Blob Storage, we'll come up to here to import data. We'll use the new import wizard. We'll select Azure Blob Storage. And since we're using the RAG pattern in order to create this vector search scenario, I'll select RAG. I'll select my storage account, the blob container we just created. We're going to grab everything within that container. We don't need to use a subfolder here. We'll leave the parsing as default. We won't enable deletion tracking, where if you remove documents and you have soft delete enabled in your Azure Blob Storage account, they would be removed from an index later on. We won't authenticate with managed identity, so we'll go next. Next, we're going to vectorize our text. This is going to be where we configure our Azure AI Foundry embedding model. So we're going to change this kind to Azure AI Foundry. Then we'll select our specific project that we deployed our model to. We'll select our model we just deployed. We'll leave the authentication type. We need to acknowledge that connecting this does mean there will be additional costs. This is because you have to pay for the input and output tokens from that embedding model that is deployed in Azure AI Foundry. So we'll click Next. You have the options to vectorize images if you have another model deployed that specifically creates embeddings based on image content. There's very specific models for this kind of thing. We're not going to do that. Enrich with your data. This is OCR. This is where you can pull text from images if you have PDFs with images of receipts or documents that have text in them or are not default text in a PDF, something like that. We also aren't doing that because our PDFs are already digital. You can enable semantic rancor. This is the ability to, when your results come back from your types of search, there is an additional step for your search to be semantically re-ranked based on the intent of the user's query. We're not going to enable this. And then you can preview the index fields if you want to see kind of what the source columns look like, what your target columns and your index will actually look like, and then the field index. If you wanted to add fields, you could do that here. I'm not going to in this circumstance. You can choose how long and how often you want your index to schedule. Right now it's only going to run once, but you can run it as many times as you'd like throughout these different types of periods. There's no harm in running your index multiple times. The downside is there is a cost for every single time you do embed new data based on those input and output tokens using the embedding model. But in terms of your usage of your AI search resource, you only ever pay for the compute in your partitions and also your replicas. We'll call this NASA ebook rag. So this will be the name of our index. Then we'll create this. We can close this, and now we'll see there are 4 new resources that were created: an index with our NASA ebook rag, an indexer, NASA ebook rag indexer, our data source, NASA ebook rag data source, and our skill set, NASA ebook rag skill set. And the way this ends up working out is that we have an indexer which reads from our data source, then the skill set transforms that data from the data source into the index. Now we can go into our index and use Search Explorer to start searching and viewing the content that we have in our index. When you're ready to take advantage of this for a RAG pattern using vector search, you'll need your URL for your AI search resource and also the API keys for your AI search resource, which you can get here or in the sections settings under keys.
Until now, we've been creating our AI search resources in the Azure portal. This is great for getting started, but as you get more advanced or may want to automate, we want to create AI search resources in code. Let's look at how we can use the Azure SDK to do just that.
Just before we get into the code, there's a few prerequisites that you're going to need. You'll need a created Azure AI search service. You'll need an Azure storage account with a blob storage container that contains the data we plan to use. And you'll need an Azure AI Foundry resource with a deployed AI embedding model. This will be used to create our vector embeddings for our Azure AI Search Index. If you don't already have these created, I've added links in the description to help you set these up. Now quickly in Azure, I want to share these 3 resources that I have with you so you see what they look like. This is my Azure search service that I have set up. I'll need the URL in just a moment when we check out the env file. This is my storage account that I'll be using. I have a container in here called Frankie's Bakery Product Catalog with a list of JSON files that are all files related to a product for a fictional business that I run called Frankie's Bakery, where we make cookies, brownies, breads, things like that. Azure AI Foundry, I have a deployed text embedding 3 small model, which is an open AI model that can create in vector embeddings from text. It's called this name with Frankie's Bakery at the end. Now let's get into the code. We're looking at the env file that we're going to be using here. Now it's super important to know you should never share your secrets with anyone. You're only seeing them because I'm going to be deleting all these resources by the time you see this video. So first we have our search resource with its key. We have our storage connection, and we have the AI Foundry resource URL, the AI Foundry resource URL key, and then the name of our deployment and the name of the model that we're using for that deployment. Here's an example of what those JSON files within that list of products, so we have an idea of what we're looking at. It's just got simple information, name, description. It's all dummy data for the sake of the way things are going to be mapped. This is the first one that we're going to get into. So when you go to set this up yourself, you'll probably want to create a Python virtual environment. This is using the Azure Python SDK. The 3 packages you're going to install is Azure Search Documents, Azure Identity, and the python.env, which is going to be used to bring in our environment variables. So there's a list of imports here that are important. You'll bring in your .env file, and then we bring in our environment variables. The first thing you got to do anytime you are using some of these Azure SDKs is you need some sort of authentication involved. We're going to be using the Azure Key Credential. In this circumstance, we have our Azure Search Key. There is the option for Managed Identity. We're not using that in this time. I've set up some prefix information so it's easy to repeatedly create resources, which this will be where the index name is, data source name, indexer name, some descriptions for the index and the indexer, and now we get into the meat. So this is the first big step, is we're going to be creating an index. And in this particular file, we're not going to be working with vectors at all. We're sticking to full text search because it's a bit simpler, easier to understand. Once we create that, then we'll move on to the way we can create vectors. So when we go to create a search index, first we need a search index client. Then we define all of our fields. This is our opportunity in the time where we get to choose, is a field going to be searchable, sortable, the different types of fields. I'm creating another video in the future that will talk all about how the fields work and how you can query using different types of fields when it's relevant. For example, with a long field with descriptions, you don't necessarily need to, sort based on a super long text field. It's not really very helpful. So you set up all your search fields here. Then we create our index, defining the index with the search index, and then actually creating or updating it. So this is our final result that we get back when we create the index. Next is our data source. Data source is where our actual data is coming from. So this is going to map data from our blob storage container to our index. And our indexer is going to be the actual resource that makes that connection happen, actually does the indexing itself. So we define the indexer client. We have our container that has the Frankie's Bakery product catalog with all of those JSON files associated with it. We set up our data source connection using Azure Blob Storage Connection with our container that is added there. And then we can create our data source using the indexer client, create or update data source connection. This creates the data source within our Azure AI Search service. Lastly, we need to create the indexer, which will tie that information from the data source to the index. In this circumstance, since we have a bunch of JSON files within our container, we need to set up some additional configuration that tells the indexer that it needs to parse the files as JSON specifically. So we have this parsing mode JSON, and we tell it to extract all the content, but also some of the metadata. We want to know the titles of the actual files themselves. And then we put it all together right here with the indexer, search indexer, and we put in the name of our indexer, description, our target index, the data source, and the indexing parameters. Then this is where we actually create it, and we should all be set up. And we'll run this. So your index is created, our data source is created, and our indexer is created. Now let's go back, we'll refresh, and see there is our new index. Right now it says 0 documents, it just got created, so it still needs a little bit of time to populate. We'll see our indexer and our data source. Should now be able to go into our index and query in it and see that our data is coming back. Now, right now, the way we have this set up is that this is all just full text search. So you would use this type of configuration if you just want to search for items based on specific keywords. But if we want to set up more semantic search capabilities using vectors, then let's set that up. So here now we're going to look at this next file. There's a little bit more involved here because when it comes to setting up the vectorization, we have a vector search profile with a specific algorithm we need to set up. We have a new field that we're going to add to our index. We have a skill set that we're going to add. So let's run through these real quick. We bring in our same environment variables with the notable change here being we're bringing in our embedding model, our embedding deployment. We're now creating a cognitive services account that's going to be necessary for our skill set. We're going to add two new fields, this merged text field and the content vector field. And really what these are is the content vector field is going to be the actual vector itself. The merged text field is a field we're going to create so that we can see the actual text that's being vectorized in its textual state. So the content vector, in order to set it up, needs to have a set of dimensions. It needs to have a search profile. The search profile needs to be defined. We have a vector search class that's being created. And it has a vector profile, which will have the algorithms set up. The algorithms uses this standard algorithm, HSNSW. It's hierarchical something. Honestly, I forget the name, but it is a standard algorithm that's used for vectorization today. Then we set up our connection to Azure AI Foundry so that the embedding model can embed the queries that come in so that they can then be compared to all of the vectors that we have in our index. Once this is set up, it associates with our content vector, and then we create our index. The data source, nothing changes. It's still just connecting to our Azure storage account. And then next is our skill set. This skill set is what's going to help the indexer understand how to take data and vectorize it so that it can properly be added to our index. So there's two different skills that are happening in our skill set. The first one is the merge skill, where we're taking information from the description and information from the tags, and we're combining them all together. So when somebody is searching, making vector queries, they're going to really be looking at the vectorized information from the description and all the tags. And that is what should be included in our merged text field. So first, the merge skill. It merges description, tags. It creates what's called a combined text field in this merged skill output. For the next skill that we have, skill number 2, the embedding skill, we're using our Azure AI Foundry embedding model to take the combined text field, so the output from our first skill, and putting it in a new target field called embedding. Then we'll add these to a list called skills, and then we'll create our skill set right here. This is the definition, and this is the creation. Finally, we come down to our indexer, where in the indexer we now need to add the skill set in. We also need to add some additional output mappings because we added the embedding from our second skill set into the embedding model. And this output mapping is now going to take the embedding and map it to the content vector model, content vector field that we have in the index. And then we also map the combined text field, which combined the description and the tags into the merge text field, again, so we can see the actual text itself. Then we create that indexer right here. So let's take a look at what this looks like. Our name for this one should be Frankie Bakery Demo with Vectors. Our index is created, our data source is created, our skill set is created, and finally our indexer. Let's take a look at the portal. And we can see in our indexes, we have our with vectors index, our indexer, which we see ran successfully, the data source for the vectors, and we should have a new skill set as well. Here's our skill set. Let's make a query and see this come back with some data. And we'll see here's the information. If we want to see the vector content come back, we can add that field in, search Explorer, and see the information from our vector. We can also see in this example too the merged text field that we have, where this lists buttery cookies packed with crunchy macadamia nuts and has seasonal, which is the product of the description and the tags.
You now know how to create resources quickly and how data works in Azure AI Search. Now, what if you want to create more complex queries? We need to know how fields work in an index to do this. Let's discuss how search fields in an index work and how you can query them.
I'm within an Azure AI Search index called Frankie's Bakery Demo with Vectors index. If I call search in the Search Explorer and I just get all this information back, I can see the data is a list of different types of products that I might have in my fictional Frankie's Bakery company, where we sell cookies, breads, brownies, things like that. Now, it's pretty difficult to see information when you always have the vectors coming back, so you can always go into the fields category within your Azure AI Search index and choose what is retrievable. This is the first field. Retrievable just tells you what is coming back when you actually make queries. The response is only going to come back with what you want. So if I uncheck some of these things, let's just uncheck a bunch so you can see the difference. We only want name, description, and product ID come back. We'll come up and save this, and in the Search Explorer, when we search, now we only get back our product name and description. You always get search score. That's part of the service itself. But these are now our results when we make that particular query. Going into fields, the next one is filterable. What is filterable? Filterable is all about filtering on the data that you have. Let's make an example query for this. In the Search Explorer, you can always come to View, change the view to JSON view, and see and make more detailed queries using JSON. I'm going to paste in some JSON to make a specific query using the filter category. This is going to filter based on the category, looking for anything that is equal to bread. When I do this, I also included the count, and I can see that my response comes back with 7 items: challah bread, multigrain bread, baguette, a couple different options here. This is using the filter category, or using the filterable field specifically on the category field name. Next is sortable. Sortable is being able to sort the actual items in your query. So let's use another query example. In Search Explorer, I'm going to put in this query to search by price descending. I'll get all the items in order by the price descending, and I'm able to now sort with this. Now, right now we don't have price in the fields, so let's add that in here. We'll save this, come back, and look at the price. Now, right now it looks like it's not sorting. I can see price, $2.11, $6, $3.16. Why is this? And it's because there's actually a default type for the way search is done in Azure AI Search. So what we actually need to add in is we need to explicitly state that the query type is going to be simple. If we don't, the standard query type also looks at metadata around your actual data itself, and it adds that to the search score. So it's not just looking only at the order by in terms of the number, it's looking at other information as well. So when we change this query type to simple, now we should see the order actually work. So 1484, 1303, and we see that the numbers are actually now descending because we added the query type simple. Next field is facetable. Facetable is used when you are trying to give a list of different types of products that have a certain amount. If you are on some sort of product page and you want to get a list of all of the t-shirts that are red, how many t-shirts are red, and how many t-shirts have 5-star ratings. This is data that you're going to want to send back to your UI so you can make those determinations. An example query of this being used, let's set up a query for all the tags and categories. And we can see the response back is we have 6 items that have a tag of bestseller, 6 items that have a tag of holiday. Scrolling down, more tags. For the categories, we see 7 of the products have a category of bread, 7 have a category of cookies, 6 have a category of brownies. And so we would send this data category and the tags back to our UI so that the UI could help a user then filter based on the facetable categories that are sent back. And lastly is searchable. Searchable is just when you are actually making queries, do the keyword search and vector search look at the actual data in that field? For example, you wouldn't search based on the price because there's very particular prices. So the AI search resource is not going to try to search and find information based on, hey, can we match this to the specific price? Same with, can we match to a specific rating? It's not searching by rating. You might sort by rating. You might try and use facetable to see the type of ratings that exist, but you're not going to use a query to search for a specific rating number. That's not what's, it's not going to be used in that way. So search is the last one. When we make searchable queries, we add a search fields field. So here's an example where we're going to see the count that comes back. We're going to search for rich, and we want to search in the fields description and name specifically. So in description and name, because they have the searchable setting set to true, we're going to look for the keyword cert rich within description and name. When we do this, we have a 5 count coming back, and so with the name and the description, we see rich in the description here, 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 rich in the description here. So that's how the searchable field works. Now lastly, this is the 5 fields, and we also have our vector here. We are yet to use the vector. So let's set up a vector query so you can see an example of how that works. coming in here, we're now adding a search for bread. This is still using keyword search. And then we have vector query, where we're doing a vector query starting with, we're going to add specifically the text. The text is going to be bread. We're searching on the content vector field, and we only want 5 coming back when it comes to the vector query. We might still get more than 5 items back because of our keyword search. And then we're deciding, hey, we only want to see product ID, name, price, merge text field come back for this particular query. Now, so because this has search up here, this is going to use keyword search, and the text bread under the vector query, we're searching using hybrid search right now. This is hybrid search. It's keyword plus vector search. So when we search this, vector merge field is not retrievable field. We get all of these items back. So there's a total of 9 because what has bread in its name will come back with keyword, and what is associated with bread because of the semantic similarity with the vector search will also come back. So sourdough loaf is an example that it doesn't have bread in its name, but it comes back because of the semantic similarity. Snickerdoodle, it's associated with these baked goods. Even though it's a cookie, it's still coming back. Probably not the best result. And baguette, it doesn't have bread in its name, but baguette is a bread, so it's associated semantically with bread. So this is how we get our results. And this is how the fields work.
Now that you know how to query AI search, let's create an Azure AI agent that uses AI search to set up Retrieval-Augmented Generation, also known as RAG.
We'll start in the Azure portal within a resource group that's currently empty. So the first thing we'll do is create a resource for Microsoft Foundry. This new resource we'll call MS Foundry, AIS, East US 2, Demo, Agentic RAG. We'll put it in East US 2. The default project name will be Proj. AIS, US2, Demo, Agentic RAG. We'll make sure we're in the right resource group. Check everything else. Run through these defaults. Leave them all as is. And create our Microsoft Foundry resource, which will also create our default project within the resource itself. Our deployment is complete. Now we can go to the Foundry portal. This automatically takes us to the new version of the Microsoft Foundry portal. We can see here the new Foundry is toggled on. If you do want to go back to the old Foundry, you can click this and continue with feedback to the old version of Microsoft Foundry, which used to be called Azure AI Foundry. But now with the new name Microsoft Foundry, we'll use the new experience within the Microsoft Foundry portal. The first thing we'll do is build our agent. We'll go to the Build tab. We'll create an agent, and we're going to call this our e-book agent because our knowledge sources are going to be using a couple ebooks. Now, right now, the way this starts is Microsoft Foundry, our project automatically by default deployed a GPT 4.1 model for us. If we want to automatically deploy one of these other models, we could do that as well. If you want to choose a different model, you can go over to Models, Deploy Base Model, search through, and choose a model of your choosing based on the criteria that you need for your particular agent. We're okay with the default GPT 4.1 model that's in place. And at this point, we can start chatting with our ebook agent just using the base knowledge that the GPT 4.1 model has from its training data. What can you do? Now, right now, there's no system instructions, so I would expect this to be pretty broad. And it's extremely general, as we would expect. Now, something we'll do here is use our generic GPT 4.1 model to actually create a system prompt that'll help our model pull from knowledge once we've added the knowledge base. Create a system prompt that'll encourage our AI agent to only pull from an AI search knowledge base with the ebook data that we upload. It gave us a simple prompt that we can use. We'll copy this, put it into our instructions, and save our agent. Now let's get started building our knowledge source. To do this, we'll go back to our resource group, and now we'll create a storage account. The storage account is where we'll have a container, and we'll place our ebooks that our Azure AI Search resource will create an index from. We'll call this SA for storage account, EUS2, demo agentic rag. Make this a basic Azure Blob storage. Primary workload will be for machine learning or artificial intelligence. We'll make it locally redundant, review and create. Now we'll go to our storage account. We'll create a new container under containers. We'll hit add container. We'll call this ebook container. Create. Then we'll upload 2 ebooks. The 2 books we've uploaded is a book called Boundaries by Henry Cloud and John Townsend, and another book by Michael Gerber named The E-Myth Revisited. One's a book on boundaries, all about keeping healthy relationships, and the other book is more of a business book, talks about how someone can be an entrepreneur, a manager, or a technician in a business. And really it's all about how small businesses can work well and succeed. Now let's go back to our resource group. And now let's create our AI search resource. And call it AI search .aas EUS2 demo agentic rag. Sure, it's an ECUS2. Keep in mind when you're creating AI search resources, they can get pretty pricey because you pay for a lot of the compute and storage that goes on to make these quick searches happen. I'll choose the basic tier for $75 a month, and I'll be deleting these resources after this demo. I'll go through, leave these defaults, and continue. Now my search resource is created. Now we'll import data to create our index. We'll go to the import data wizard, select Azure Blob Storage. We'll choose RAG for our scenario. We'll choose our storage account, which is the agentic RAG storage account, our container. We'll leave the default folder because we just want everything within that container. The parsing node is default since we're parsing PDFs and not another type of special file. We won't enable these. Deletion tracking or managed identity. Go to next. For the kind, we're going to choose to make this Azure AI Foundry, which it should be Microsoft Foundry, but that'll get updated soon. We'll choose the project that ends in agentic RAG, because that is the project we just created. The model that we'll use to create the embedding vectors is our text embedding 3 small model. This is a model that was deployed automatically for us to Microsoft Foundry when we first created the project. So using that to create our embeddings, we'll leave the API key as the authentication type. We'll acknowledge that the tokens that are used to generate the embeddings, both for queries to AI search and also by the indexer to create the vector embeddings, are going to incur some costs. Then we'll go to next. We won't be using these additional enrichment skills. I will leave enable semantic ranker checked, which adds an additional step to enhance the search results by re-ranking them based on the semantic intent by a user's query. I can preview and see what the index fields will look like. Mostly they are just the chunked up version of the different files. If the files are big, which they are because they're ebooks, the parent ID is the specific ID to the book file itself. The chunk will be the specific data that is in that chunk. The text vector is the vectorized version or the embeddings of that chunk, and then the title is the literal title for the parent ID or that ebook file. Save this. We'll have the index only run once. We'll call it ebook agentic rag, and we'll create our index. This should create an index, an indexer, a skill set, and a data source for us within our AI search resource. Should now be able to go to search, start searching. My indexer is still running, so I wouldn't expect information to come back because it's still, the indexer should still be working. If I go to indexers, I can see it's in progress. We'll come back when this is done so we can see an example query to our index. Our indexer is done. Let's go to our index, make an example search where we'll just search for everything. We can see data coming back along with those vector embeddings. If I go into fields and I uncheck the retrievable for text vector, this will make not all the embeddings come back when I search this, making it a little bit easier to see the information that's coming back. So I can see an example of documents within this index coming back. So when we make queries to our agent, we will expect the agent, when it has an AI search tool connected to it, to make queries based on what we're asking for, where it will try to retrieve these documents from the index to send back to the agent and allow the agent to respond based on this additional context. Now let's go back to our agent and add this in. Our ebook agent will go to knowledge, connect add. We'll set up a data source via tools where we'll connect our Azure AI Search resource. Right now there's currently no connections. Let's create a new connection to our AI search resource. We'll choose the one that ends in agentic rag. That's our AI search resource. Now that a connection has been made, we'll choose our index and we'll add it in. We now have our agentic rag set up. And if we go ahead and make a query asking about the information regarding those books, we should get information back specific to the contents of those books. What is the definition of a boundary according to John Townsend and Henry Cloud? So I can see this query that I just made. What's the definition of a boundary according to John Townsend, Henry Cloud? I see this reference to the boundaries book, which shows that our AI search resource is working. I can also check out the debug tool and see that the tool is called. So now our agentic rag setup is complete. When you're ready to implement this into your code, you can go ahead and see this code example and put that into a Python, JavaScript, or C# example. You also have the option to preview this with a preview sample code that has been set up for you with Microsoft Foundry if you wanted to test this and even share it with people within your organization. You can also publish this agent so that you can quickly make it available on Microsoft Teams or Microsoft 365 Copilot.
You should now have a deep understanding of how Azure AI Search works, and you can take advantage of it now for your AI apps and agents. If you have questions, please leave them in the comments below. I answer every comment to help as many people as I can. If this video was helpful for you, I'd appreciate it if you liked the video and subscribe to this channel if you want to see more content like this. As always, thank you so much, and I'll see you in the next one.